Okay, welcome back. No, I'm not quite sure if my microphone is working on this, but bear with me. Okay, I'm just going to run it as it is and see, hopefully it will come out correctly. Excuse me. But what I want to look at today is AC motors, okay? And AC motors, makeup and construction, okay? Now, here we're looking at an AC motor construction, and we're looking at the asynchronous AC induction motors. Are commonly used in industrial applications. An asynchronous motor is one in which the rotor speed differs from the speed of the rotating magnetic field. So what you have a magnetic field setup created by these coils. Okay. Now, if that rotor speed was to match the magnetic field, then that would mean that there is no rotation. It will simply stop. Okay, so you must have some kind of difference between the rotor field and the stator field. Okay, now just recapping, an asynchronous motor is one in which the rotor speed differs from the speed of the rotating magnetic field. Okay, so let's just go and see this a bit closer. Okay. In general, for AC induction motors, this means that the rotor speed will be less than the synchronous speed of the rotating field due to slip. Okay, so here we have a slip between the rotor and your magnetic field. Now, the illustration shows a typical three-phase 460 volts AC asynchronous induction motor. Its three primary parts are the rotor, the stator, and the enclosure. Okay, so let's look at this in full. Here you can see your enclosure, stator, or that's your stator field, okay, and your rotor. The enclosure is your main body that houses the motor itself. These are your stator with the windings and your rotor. Okay. Now the stator core, let's go back to that now. Okay. Stator core. The stator core consists of a core made of thin stacked laminations that are wound with insulated wire. As previously described, when current is passed through this wire, the stator acts as an electromagnet. Several hundred laminations are stacked together to form the core, and here's just a sample of your laminations. Okay. And here's your stator core laminations. Okay. These slots here is where the cable are inserted. So you can see that here, okay? That's where that is happening. That's where your cables are formulating your stator field. let's just make sure that we have all this for you. Okay. Okay, let's take a long shot. Okay. Now here we're going to look at the stator coils. The stator laminations are stacked together to form a hollow cylinder. Coils of insulated wire are inserted into slots of the stator core, usually along with stiff paper insulators. Okay, and on here all we're doing now is showing you how that is done in regard to the stator. Okay. And here you have your insulated paper cores, and the windings goes right through, okay, round in turn, and that's continued around each of these stator inserts. Okay. So the stator core, okay, paper insulators, and insulated wire coils. Okay, let's just get that up a bit more. Okay. Okay. Support a little bit and now go back in. Okay. You can see this in full. Okay. Okay. Now here we're coming through the stator electromagnet and stator electromagnet. Each grouping of coils, together with the steel core it surrounds, form an electromagnet. The stator windings are connected directly to the power source. Okay. And here we have the finished stator core. Okay. Okay. Now stator core, okay, insulated wire coils. And here we have the finished product, okay, and that forms your stator core, and that sets up and produces your electromagnet. Now here we have the rotor. Now I was trying to see if I could get this text larger, but I can't. So I'm going to have to take it from a wider angle. Okay, but let's just go in a little bit and the most common type of rotor is the squirrel cage. So named because of its resemblance to the exercise wheels found in rodent cages. Okay. And here we have that already here. Okay, that's what that refers to. Now, how this is made up is reflected by here. Shows us in now here the rotor consists of a stack of steel laminations with evenly spaced conductor bars placed around the circumference. Okay, and these become your conductor bars. Okay, and these laminations, these are kind of little slices of steel, if you like, and these here makes up this. Okay, so here we have conductor bar slots, and these are around here completely. So let me just go with the text in full. Look a little bit now, we can get everything in. Okay. Conductor bar slots. Okay, let's bring that into play. Set up there. Okay. Let me just go back and make sure that we can get everything in. Okay. That seems good.